So today we're going to do page 43, 1 through 19 odd. So if you open to page 43, you'll notice that we're going to deal with rational functions again. So you see fractions that have variables in both the numerator and in the denominator. And we did this last year. So let's have a quick refresher. What if I had something like 1, let's say 1/9 plus 3, let's say 6. Well, that's 3/6 doesn't make a lot of sense. How about 5/6? How do I add two fractions together? I need a common denominator, and to find a common denominator, I need the factors of the denominators. So this one is 3 times 3, and this one is 2 times 3. So what does my common denominator need? Well, my common denominator is going to include enough of every number to cover each of the denominators that already exist. So the denominator is going to be made up of 2's and 3's. How many 3's does the common denominator need? Well, what is the common denominator of 9 and 6? 18. They both go into 18. Well, 18 is just 2 times 3 times 3. So really what we're doing is we're saying, okay, there's 1 3 here and 2 3's there. How many does the common denominator need to cover both? Well, it has to have as many as the largest set. So this belongs in the common denominator. And on the other side, it has to have a 2. But there's only 1 2. So I need 1 2 and 2 3's. And I look at this. Do you see everything here in the common denominator? Yes. Do you see everything here in the common denominator? Yes. And that's how you tell. You look at the factors, and the common denominator has to have, it needs to have enough information to cover all of the previous denominators. So when we do the actual math, what does this left fraction need in order to be equal to the common denominator? It needs a 2. So we multiply by 2 over 2. And notice, 2 times 9 is 18. And on top, I get 2. Plus, what does this need in order to equal the common denominator? 3. So I times it by 3 over 3. And this equals 18. And now I have 15 on top. So 17/18 is the answer. Okay, let me try one more. So let's do 18 and 20. So 7/18 minus, let's not do that. Let's do 7/20. So 18 is made up of 2 times 3 times 3. What's 20 made up of? 5 and 4, which becomes 2 times 2 times 5. So what belongs, how many 2's does the common denominator have to have? 2. Could I put in 3? Yes, but then I'd have to simplify my answer by dividing out that extra one. So I look here, we have a single 2 there and a double there, so the common denominator has to have at least 2. So 2 times 2. What else does it have to have? At least 2 3's, 3 times 3, and 5. Now, I can put in extra stuff if I want, but that extra stuff will simplify in the end, so it's not worth it. So you don't want to put in extra stuff. So then I look, what does this need that this has? A 5 and a 2. So I'm going to times this by 10 over 10. And then what does this need that the common denominator has? 2 3. So I'm going to times this one by 9 over 9. So 10 times 7 is 70, minus 7 times 9, 63. And the common denominator is, so 5, that's 15, times 3 is 45, times 2 is 90, times 2 is 180. So it's over 180. And you can see this is 180, and that is also 180. So 7 over 180. Does that simplify? No, because 7 is not in that list. If it did simplify, then we would just simplify it. So, take a look at page 43. We're going to be dealing with common denominators here. But first, it says, specify any values from the solution set that must be excluded from the solution set and then solve the rational equation. Are there any answers that simply can't be part of the solution? 2 and any others? No. So where did you get the 2 from? If you set this equal to 0, then you would have x, you would have 2 divided by 0, which is infinity, which we can't graph on the number line, so it doesn't count. So in order to solve this, we need to have a common denominator. So first I'm going to write x is not allowed to be 2. So that's 5 over 1. What do I need to do in order to make that a common denominator? I need to times it by the factors that are here. Do I want to times it by x minus 2 twice? I could, but then I would simplify something out in the end, and it's not worth it. So this needs to be multiplied by x minus 2 and x minus 2. And that gives me x over x minus 2 plus 5x minus 10 over x minus 2 equals 2 over x minus 2. Oh, that's interesting. Now what? Well, is the denominator still important? Why not? They're all the same. So if I had 8 fifths plus 6 fifths equals 14 fifths, if I just went through and deleted all those 5s, is that statement still true? Yes, but whenever you get rid of variables, you always eliminate solutions or possible non-solutions, but we've already stated, that didn't work, we've already stated that x is not allowed to be 2. So go ahead and eliminate the x minus 2 as long as you remember, if the answer we get is 2, it's not really the answer. Okay? So we get x plus 5x minus 10 equals 2. These make 6x, subtract the 10, 12, divide x equals 2, but it's not allowed to be 2, so the answer here is no solution. Which means, yeah, if you were to, let's say we subtract this over and set it equal to 0 and we graph it, I don't know what it's going to look like. I mean, something like this maybe. 1, 2. But what actually happens at 2? There's a hole there. Or it might also be an asymptote. It's actually probably an asymptote. So it probably looks more like this. And there simply is no graph at 2, and that's the answer we were looking for. Okay? So take a look at number 3. Just the odds. So, yeah, well, Do you know, I mean, can you handle 3? Okay, that's fine. We can move on to 7. 7's a little more complicated, but it's the same basic idea. I have 3 denominators, n, n plus 1, and n times n plus 1. So what is my common denominator going to be? N times n plus 1. Now I could make it worse. I could say n squared times n plus 1 squared, but then you'd have to divide it out in the end. It's not worth it. So what does this side need? An n plus 1. Okay, and what does this side need? An n. What does this side need? Nothing. It already has everything. Okay, so this first one gives me n plus 1 plus this one gives me n equals, that one's already negative 1, and I can drop the denominator as long as I remember n is not allowed to be negative 1 or 0. Because both of those would give me an undefined function. So this is 2n, I'm going to subtract 1, equals negative 2. Divide by 2, and n equals negative 1. But once again, that is not allowed, so this particular function has no solution. So there's either a hole or an asymptote where the answer is supposed to be. Okay, now that's not going to happen every time. So 11, well, we better set up 11. So let's factor this denominator. We could take out a 2 and a 3. So this is actually 2 times 3 times n minus 1. This is 3 times 3. And this one is 2 times 2 times n minus 1. So what does the common denominator look like? 2 times 2 times 3 times 3 times n minus 1. So my common denominator is 2 times 2 times 3 times 3 times n minus 1. Okay? So what does the first fraction need? Another 2 and another 3, so I'm going to times these by 6. What does the second fraction need? So a 4, a 2 times a 2, and an n minus 1. So 4 times n minus 1. And what does the last fraction need? 2 3s, so I'm going to multiply this by 9. And I need to remember n is not allowed to be 1. So we have 6n minus 30 equals 4n minus 4 minus 9n minus 27. Did I mess that up? Okay, so really, in the end, this is negative 9n plus 27. And you'll solve that, and just remember, n is not allowed to be 1. If that happens to be the answer, then there's no solution. Okay, turn the page. For number 13, what is the common denominator going to be? Can we pull anything out of this? No, so that is one of the factors. Can we pull anything out of that? No, so what's my common denominator? 5x plus 1 and 2x minus 1. Okay? 15 you can handle, 16 you can handle, 17 you can handle, and I think you can do 19. Okay, get to work. Good luck.